Imagine, if you would, that you are sitting in the deepest part of the night. Not the kind of night that surrounds you in your room, though perhaps it does, but the kind that exists in the spaces between stars. You are suspended there, floating in that ancient darkness, weightless and calm, as if the universe itself is cradling you in a blanket of profound silence. There is no sound up here, no wind, no traffic, no voices calling from distant rooms. There is only the gentle presence of emptiness, and within that emptiness, something has just begun to whisper. Something has just started to speak to us from the very edge of what we thought we understood about reality itself. You see, not very long ago, just months before you were listening to these words, just moments in cosmic time, one of humanity's most remarkable instruments looked deeper into the universe than any eye has ever looked before. We call it the James Webb Space Telescope, and it hangs there in the darkness, about 1 million miles from where you rest, peering backward through time itself, watching light that has been traveling toward us for over 13 billion years. And that instrument, that astonishing creation of human curiosity and engineering, has found something that shouldn't exist. Or rather, it has found something that makes every model, every equation, every understanding that Einstein and physicists since have built seem suddenly incomplete. And before we drift any further into this mystery with you, if you find comfort in journeys like this one, in stories that unfold slowly and gently into the deepest parts of the night, you can support this channel in a way that feels as natural as breathing. Simply like this video if the exploration resonates with you. Subscribe to join us on future voyages through the cosmos. And if you feel moved to do so, share where you're listening from. Somewhere out there in the world, perhaps in your own little pocket of darkness and peace. Thank you for being here. Now, let us return to that edge of understanding where everything is about to change. For more than a century, we have lived in Einstein's universe. Not because we chose to, but because the mathematics worked. Because when Einstein sat down and imagined what it would feel like to ride on a beam of light, when he worked through the elegant consequences of that daydream, he created a portrait of reality that held up against every test we could devise. Time slows down when you move very fast. Space curves around massive objects. Gravity is not a force pulling you down, but rather the shape of space itself, bending beneath the weight of stars and planets. These ideas seemed almost impossible when they first emerged from Einstein's mind, and yet they explained everything from the orbit of Mercury to the way light bends around the sun to the existence of black holes themselves. But there is always a moment, in the pursuit of understanding, when the universe decides to teach us humility. When reality reveals that our careful models were only partial truths, beautiful sketches of something far more intricate than we imagined. And this moment, this exact moment in human history, may be one of those profoundly humbling instances. Let your mind settle for a moment. Imagine the James Webb Space Telescope, that golden eye, that magnificent instrument that cost so much to build and took so long to reach its destination. For decades, scientists and engineers worked in silence, making calculations so precise that the telescope's mirror segments could be adjusted with exactness measured in nanometers, distances so small that billions of them would fit on the head of a pin. They sent this creation out into the void, and it has not disappointed them. It has revealed galaxies so ancient that we can barely comprehend their age. It has shown us how stars form from clouds of dust. It has pierced through cosmic clouds that visible light could never penetrate. And in doing all these things, in looking backward through time, it has stumbled upon something unexpected. The universe appears younger than it should be. The galaxies appear more mature than is possible. The cosmic structures that should have taken billions of years to form seem to have assembled themselves in what amounts to the universe's infancy. And yet, there is more. There is something even stranger lurking in the data, in the spectrums of light, in the whispered messages that photons have carried across the vast ocean of space and time. There are hints, subtle, tantalizing hints of evidence that challenges the very foundations of our understanding of how the universe began, how it expanded, how it continues to change even now. Some researchers have begun to propose something extraordinary. What if, they wonder, what if the Big Bang, that moment of infinite density and infinite temperature that we imagined as the birth of everything, what if that event was not, in fact, the beginning of everything? What if the Big Bang was merely a phase transition, the way water freezes into ice, a transformation of something that already existed? What if our universe, solid and real as it seems, is simply part of something larger, something that cycled and transformed before our current cosmic epoch began? Let that thought settle gently in your mind, not as something frightening, but as something quietly astonishing. The idea that what we call the beginning was perhaps not a beginning at all, but a metamorphosis, a rebirth of something old into something new. This is not mainstream science yet. This is speculative. This is the bleeding edge of theoretical physics, where imagination and mathematics dance together in the darkness. But it is no longer mere fantasy. It is something that serious physicists are beginning to consider, something that the observations from the James Webb Space Telescope have begun to whisper might be true. And yet, as we float here in the peaceful dark, thinking about these vast and incomprehensible scales, about the possibility that our universe is younger than we thought, or that what we imagine as the beginning is really something far more subtle, there remains a question that unfolds like a lotus opening slowly in moonlight. How did we arrive at this moment? How did we come to understand so much about the cosmos that we could discover how little we actually understood? How did human beings, standing on this small planet orbiting an ordinary star, develop the capacity to look back in time itself and begin to perceive the secrets of creation? These are the questions that will guide us as we continue this journey together through the night. And they are questions that matter, not because they provide answers that will change your daily life, but because they expand the boundaries of what it means to be human, to wonder, to ask, to pursue understanding, even when that understanding hints at mysteries deeper than we imagined. As you listen to these words, perhaps you are beginning to relax more deeply. Perhaps your breathing is becoming slower, more rhythmic, more aligned with the ancient rhythms of cosmic expansion and contraction. This is good. This is the natural response of your mind and body to the contemplation of scales so vast that all earthly concerns become, for a moment, beautifully small. Your worries, your anxieties, your daily frustrations, they exist at a scale so different from the birth of galaxies, from the expansion of space itself, that for this moment they can simply be held gently aside. But there's more to this than contemplation alone. Because as we look deeper into what the James Webb Telescope has revealed, we find ourselves navigating through layers of mystery, each one more fascinating than the last. We find that the universe is not only stranger than we thought, but stranger than we are capable of thinking. And somewhere in that strangeness lies a truth that is waiting to unfold, a revelation that will reshape how we understand our place in the cosmos, and perhaps how we understand ourselves. So let us continue. Let us drift deeper into this mystery, as the universe itself drifts deeper into its future. Let us ask the questions that matter most, and let us find, in the process, that the searching itself is a kind of peace. And so we begin, truly, to descend into the specifics of this cosmic mystery. But before we do, I want to guide you somewhere in your mind. Picture yourself standing in an observatory, a place high above the clouds, where the air is thin and clear. Around you are photographs and data displays and instruments of every kind. Scientists move slowly through this space, speaking in hushed tones, as if they are in a sacred place. And perhaps they are, because this is where humanity touches the infinite. This is where curiosity and precision meet. And it is in places like this, in quiet moments of analysis and reflection, that the greatest discoveries are often made. The James Webb Space Telescope did not simply appear in the sky one day. It was a dream that took decades to realize. Imagine scientists sitting in offices in the 1990s, sketching designs for something that would not launch until 2021. Imagine engineers solving problems that had never been solved before. Imagine the sheer audacity of it all to build something so sensitive, so capable, so extraordinary that it could see light from the universe's earliest epochs. Light that had traveled for longer than human civilization has existed. Light that carried with it the history of creation itself. And when the telescope finally took its first images, when those golden mirrors were unfolded in the vacuum of space and began to receive the ancient photons streaming toward us, what humanity discovered was both wonderful and unsettling. The images showed galaxies far older than they should be. Now, I want you to understand what this means, because it is crucial to the story we are telling. When astronomers look at distant galaxies, they are looking back in time. The light from a galaxy 12 billion light years away takes 12 billion years to reach us, so we see that galaxy as it was 12 billion years ago. It is like looking at a photograph of someone as they were in childhood, when they were much younger. The farther away the galaxy, the younger the universe was when that galaxy formed. So when James Webb looked at galaxies that exist in the universe's first billion years, scientists expected to see relatively simple structures. Galaxies that were still forming, still young, still chaotic and disorganized. They expected to see the building blocks of cosmic structure, small clumps of stars that would eventually merge and mature into the great spiral and elliptical galaxies we know today. But what they found was different. They found massive galaxies. They found galaxies with billions of stars. They found galaxies that appeared fully formed, mature, complex. They found galaxies that should have taken billions of years to assemble, appearing instead in the universe's first few 100 million years. Imagine that. The universe is only 13.5 billion years old. And here were objects that appeared to require more time to build than the universe had actually existed. This discovery sent ripples through the scientific community. Papers were published. Conferences were held. Physicists and cosmologists looked at the data again and again, searching for some way to reconcile what they were seeing with what they had always believed. Perhaps there was an error in the measurements. Perhaps the telescope's calibrations were off. Perhaps the mathematical models used to interpret the light were incorrect. But examination after examination revealed something troubling. The observations were not an error. They were real. And then, slowly, other hints began to accumulate. The color of these galaxies seemed strange. The way they were distributed through space did not match predictions. The amounts of certain chemical elements within them suggested histories that were impossible according to standard models. These galaxies should not have had time to produce so many heavy elements. These galaxies should not have had time to grow so large. These galaxies should not exist. And yet they did. This is where the story begins to become truly fascinating, because science does not ask us to accept mysteries. Science asks us to solve them. And so physicists began to think very carefully about what these observations might mean. They considered many possibilities. Perhaps the universe was not as old as we thought. But no, the evidence for the age of the universe is overwhelming, drawn from many independent sources. Perhaps the early galaxies had formed from matter that fell together more quickly than expected. But even with all the physics we could invoke, the timescales did not work. And then, as these questions hung in the air like morning mist, some researchers began to propose something bolder. What if the problem was not with the galaxies themselves, but with our fundamental understanding of how the universe began and how it has changed over time? What if something about the Big Bang, that cornerstone of modern cosmology, was not quite right? Imagine you are drifting now, floating through these concepts as if they were currents in a vast ocean. You need not grasp them all at once. You need only allow them to flow past you, and gradually, like sediment settling through still water, they will come to rest in your consciousness. The important thing to understand is this. The James Webb Space Telescope has shown us that either our understanding of cosmic history is incomplete, or something very different happened in the early universe than we had imagined. And this realization, this gentle but profound realization, is the beginning of everything that follows. Yet even this is not the deepest mystery. Even this is not the strangest thing that the data has begun to reveal. Because as researchers look more carefully at these observations, as they examine not just individual galaxies, but the patterns that galaxies create together, they have begun to notice something else. Something that touches on an idea that some physicists have entertained for years, a hypothesis so extraordinary that it almost seems impossible to say aloud. But we will say it. We will speak it gently into the night. What if the universe we observe is not the first universe? What if what we call the Big Bang was not the true beginning, but rather a transition, a rebirth, a cosmic metamorphosis from something that came before? Think about this for a moment. Allow it to settle into you like a stone entering still water, creating ripples that spread outward, infinitely outward. Our entire civilization is built on the assumption that time began roughly 13.5 billion years ago. That before the Big Bang, there was nothing. No time, no space, no possibility. Pure nothingness. This has always seemed like the ultimate truth, the foundation upon which everything rests. But what if we have misunderstood? What if there was something before the Big Bang? Not quite the universe as we know it, but something different. Something that existed under different laws of physics. Something that eventually transformed, condensed, reorganized into the universe we observe today. Greeks called this idea eternal return, the notion that cycles of creation and destruction repeat endlessly. Modern physics has generally rejected such ideas as unscientific speculation. But James Webb's observations have begun to suggest that perhaps, just perhaps, some version of this ancient intuition might contain a grain of truth. And yet, you must understand, this is not established science. This is hypothesis. This is speculation. This is the frontier where knowledge becomes uncertainty, where the maps of the universe are still being drawn. But it is founded on real observations, real data, real measurements made by our most advanced instruments. And that is why it matters. That is why this moment in human history might be remembered as the moment when we began to realize that the universe is far stranger, far more wonderful, far more mysterious than we had dared to imagine. As your mind settles into this contemplation, as your body relaxes into the embrace of possibility and wonder, know that we are only beginning. We have opened a door. We have glimpsed something beyond. And now we must walk through that doorway together, into the deepening darkness, toward a truth that is still crystallizing, still becoming clear. Allow yourself to drift backward in time now. Not billions of years backward, but only a century or so. Imagine the early 20th century, a time when the universe was understood to be static and eternal. It was a cosmos that had always existed, unchanging in its essential nature, with our galaxy, the Milky Way, comprising the entirety of the known cosmos. Stars were fixed points of light that had always been there and would always be there. Planets orbited stars. The universe simply was. It did not change. It did not evolve. It did not have a history. And then came Einstein. This man, with his wild hair and his ability to think in ways that defied convention, proposed something that seemed almost absurd. What if space and time were not fixed and absolute, but relative and flexible? What if gravity was not a force, but the curvature of space itself? What if massive objects like stars bent the fabric of space around them, the way a heavy ball placed on a rubber sheet creates a depression? These ideas were revolutionary. They were incomprehensible to most people. And yet, gradually, they were confirmed through observation after observation. But here is what makes the story truly interesting. Einstein himself did not initially accept one of the most important consequences of his own equations. The mathematics suggested that the universe could not be static. It had to be either expanding or contracting. It could not remain unchanged. Einstein found this so troubling that he added a term to his equations, a mathematical fudge factor, to make the universe static again. He wanted the universe to be stable, eternal, unchanging. It was not that the mathematics forced this conclusion. It was that Einstein's intuition rebelled against the alternative. Yet reality, it seems, is not interested in what we want it to be. Reality simply is what it is. And in the 1920s, an astronomer named Edwin Hubble made observations that would change everything. Using a telescope in California, Hubble discovered that the Andromeda galaxy, which had been thought to be part of the Milky Way, was actually a separate galaxy, far beyond our own. And more remarkably, he discovered that this galaxy, and all the other galaxies beyond ours, were moving away from us. The universe was expanding. This expansion was not even, moreover. Galaxies that were farther away were receding faster. This suggested something profound. If you reverse time, if you played the cosmic expansion backward, the galaxies would come back together. They would collide. They would compress. If you reverse time far enough, all the matter in the universe would come back to a single point. A moment of infinite density and infinite temperature. A moment from which all existence emerged. This idea was revolutionary. It was troubling. And yet, the evidence was mounting. And then came more discoveries. In the 1960s, scientists detected a faint glow of radiation filling the entire universe. It was like the afterglow of a cosmic fire. This radiation, called the cosmic microwave background, was exactly what cosmologists would expect to find if the universe had indeed begun in a hot, dense state and had been expanding and cooling ever since. Here was evidence, written in the radiation itself, of the Big Bang, of creation, of beginning. As decades passed, more pieces of the puzzle fell into place. The ratios of different chemical elements observed in the universe matched predictions for how they would have formed in the first few minutes after the Big Bang. The structure of galaxies and clusters of galaxies matched predictions from theories of how small quantum fluctuations in the early universe would grow through the influence of gravity into the vast cosmic structures we observe today. Everything fit. The model worked. It was beautiful. It was elegant. It seemed to be the true story of creation. But now, slowly, gently, almost imperceptibly, the picture is beginning to change. Not because the old observations were wrong. Not because the Big Bang theory is being abandoned. Rather, because new observations are suggesting that something is missing, that the story, while broadly correct, is incomplete, that there are layers of truth beneath the surface that we have not yet perceived. This is the nature of scientific progress. It is not a sudden revolution, but a slow, relentless unfolding of deeper understanding. It is like moving through layers of an onion, each layer revealing what is beneath it. We are not abandoning what we know. We are deepening it. We are expanding it. We are learning that reality is more subtle, more complex, more wonderful than we had imagined. And this is where James Webb enters the story. This telescope, which some have called the successor to Hubble, was designed to see farther and clearer than any previous instrument. It was designed to look back to the very earliest galaxies, to the time when the universe was only a few 100 million years old. It was designed to test the predictions of our models, to confirm what we thought we knew. And instead, it has begun to show us that we do not know as much as we thought we did. Imagine you are an explorer, standing on a shore and looking out at an ocean. For centuries, cartographers have sketched the coastlines they can see. They have made models of how the currents flow. They have charted the islands and the reefs. The maps are useful. They are broadly accurate. But then you board a ship with better instruments. You sail into the ocean, and you discover that the reality is far more intricate than the map suggested. There are currents that flow in unexpected directions. There are undersea mountains that were never charted. There are places where the water swirls in ways that defy the simple models. This is where we are now. The universe is revealing its deeper intricacies. The simple models, while not wrong, are incomplete. And in the process of trying to understand what James Webb has shown us, physicists have begun to ask questions that touch on the most fundamental mysteries of existence. What is time, really? Did it begin with the Big Bang, or does time extend further back into some realm we have not yet discovered? How did the universe come into being? Was there truly nothing before the Big Bang, or was there something? Some other state of reality that we cannot currently perceive? What is the relationship between our universe and the laws of physics that govern it? Could there be other universes? Other realities? Other ways that matter and energy could organize themselves? These are not questions for tomorrow. These are not problems for some distant future. These are questions that scientists are asking right now, guided by the observations that James Webb has provided. And as we explore these questions together, as we wade into the philosophical depths that they reveal, we are engaging in something that is at the very heart of what it means to be human. We are asking the eternal questions. We are seeking understanding. We are attempting to comprehend our place in a cosmos that seems determined to remain, at its deepest level, mysterious. So continue to breathe slowly. Continue to relax. Continue to allow these concepts to unfold in your mind like flowers blooming in a garden, slowly, inevitably, beautifully. We are making progress. We are moving deeper into the mystery, and the journey is far from over. Now we come to a place of particular fascination, a place where observation and theory meet in an uneasy tension. Let me paint for you a specific image, and in this image, the paradox becomes clear. Close your eyes if you wish, and imagine this. You are traveling backward through time, not consciously, but in your imagination. You are watching the universe as it was, younger and younger, moving back thousands of years, millions of years, billions of years. The galaxies around you are getting closer together. The universe is hotter, more dense, more chaotic, more turbulent. You travel back 13 billion years, then 13.1 billion years, then 13.2 billion years. You are approaching the earliest moments of the universe that we can see. Now imagine you arrive at a time when the universe is only 600 million years old. To put this in perspective, that is less than 5% of the universe's current age. If the entire history of the universe were a single day, this moment would be barely past dawn. The first rays of sunlight would just be breaking over the horizon. The world would still be mostly dark. And yet, in this moment, in this ancient epoch, what do you observe? Galaxies, not small, chaotic, primitive galaxies. Not clouds of gas and dust just beginning to coalesce, but galaxies, massive galaxies with billions of stars. Galaxies that appear fully formed, mature, complex. Galaxies that possess all the intricate architecture of galaxies in our own era spiral arms, stellar populations of different ages, supermassive black holes at their centers. These galaxies look like adults that somehow emerged from the womb as fully grown humans. The problem, you see, is a problem of time. There is simply not enough time for galaxies to grow this large through the mechanisms we understand. Stars form from clouds of gas. Clouds take time to collapse. Stars are born. Stars burn through their fuel. Stars die. Black holes grow by consuming material. This all takes time. Galaxies merge with other galaxies, and these mergers take time, and they require that the smaller galaxies exist in the first place. All of these processes, working together, should require many billions of years. And yet, here they are, accomplished in only a few 100 million years. This is not a minor discrepancy. This is not something that can be easily explained away by minor adjustments to our models. This suggests that something fundamental about our understanding is incomplete. Imagine a bricklayer. He is given a pile of bricks and told to construct a magnificent cathedral. He knows that if he works for a year, he can build a modest building. But he is told that he must construct the cathedral in 2 weeks. The bricks are there. The mortar is there. The blueprints are there. But the time constraint seems impossible. The bricklayer does not lack skill or resources. He simply lacks time. And yet the cathedral is there, completed, standing before him. How? There are several possibilities. Perhaps the bricklayer is far more skilled than anyone knew, and he can work faster than any previous bricklayer. Perhaps the bricks are not as heavy as expected, and they can be assembled more quickly. Perhaps other workers arrived at night and helped, working without the bricklayer's knowledge. Or perhaps, and here is the troubling possibility, perhaps the cathedral is not actually new. Perhaps it was built at some other time, in some other way, and was only recently transported to this location. Cosmologists are now considering similar possibilities about these ancient galaxies. Perhaps the early universe operated under different physical laws that allowed galaxies to form faster. Perhaps dark matter, the mysterious substance that comprises most of the universe's mass, concentrated more efficiently than we expected. Perhaps what we are seeing is not a contradiction in the data, but a misunderstanding of what the data represents. Or perhaps, and this is what leads us to the deepest mystery, perhaps these galaxies formed in a previous universe before the Big Bang, and their light only recently entered our observable universe through some mechanism we do not yet understand. You see, this last possibility is the one that troubles physicists the most, and the one that excites them the most, because it touches on that has haunted cosmology for decades, the question of what came before, the question of whether the Big Bang was truly the beginning, or whether it was a transition, a boundary between one cosmic epoch and another. Think about time in a different way for a moment. In our daily experience, time flows in one direction, from past to future. We remember the past, but not the future. We can influence the future, but not the past. This is the direction of time's arrow. But this arrow is not fundamental to the laws of physics as we understand them. At the level of atoms and subatomic particles, the laws of physics work just as well backward as forward. An electron moving backward in time behaves the same as an electron moving forward in time. So why does time have a direction? Why does the arrow point forward? One answer involves entropy. The second law of thermodynamics tells us that disorder increases over time. A hot object in a cold room will eventually cool down. A drop of ink in water will disperse throughout the water. And these processes are irreversible. They proceed only in one direction. And this, many physicists believe, is what gives time its direction. The universe begins in a state of extraordinary order, infinite density, and then disorder increases as time progresses. This is the arrow of time. But what if the Big Bang was not actually a state of infinite order? What if it was, instead, a transition from one state to another, a phase change, like water freezing into ice? In that case, the concept of before the Big Bang becomes problematic. You cannot ask what came before a phase change. You can only ask what the previous phase was. Some physicists have proposed models where the universe cycles through phases. An old universe ends in a state of extreme density and temperature. This leads to a phase transition. The new universe begins. An extremely different state of physics might govern each phase. But from the perspective of an observer in the new phase, the transition appears to be the beginning of time itself. What if that is what we are seeing? What if the James Webb observations of impossibly old galaxies is evidence that our universe inherited them from a previous cosmic phase? That the light we are observing today traveled through both epochs, both universes, before reaching us? That what we call the Big Bang was not creation, but transformation? This is deeply speculative. This is at the edge of what can be taken seriously in theoretical physics. But it is not unscientific. It is not unthinkable. It is, rather, an attempt to reconcile the observations with the laws of physics, to find explanations for the puzzles that James Webb has revealed. And as you listen to these ideas, As you allow them to drift through your mind like clouds through a sky, you might begin to feel something else, a sense of wonder, a sense of humility, a recognition that the universe is far more complex, far more mysterious, far more beautiful than we had imagined. And that is exactly what science should inspire in us. Not certainty, but wonder. Not arrogance, but humility. Not the belief that we have solved the greatest mysteries, but the recognition that we have barely begun to ask the right questions. The paradox of the mature ancients remains. These galaxies exist. They are not illusions. They are not errors in the data. And they are telling us something. Something important. Something that changes everything. Let us now consider something even more profound. Let us think about light itself. Light is not merely a phenomenon. Light is information. Light is history. Light is a messenger that carries the story of the universe across the vast emptiness of space. Everything we know about distant galaxies, about the early universe, about the cosmos beyond our solar system, comes from light. We do not send spacecraft to observe other galaxies. We do not physically travel to distant times. We can only observe the light that has journeyed across billions of years of space, carrying with it information about the sources that emitted it. Light is our only connection to the distant cosmos. And light, we must remember, is bound by the speed of light. It cannot travel faster than its own speed. And so when James Webb observes a galaxy 12 billion light years away, that light has traveled for 12 billion years to reach us. But here is something subtle that we must consider. The universe is not static, it is expanding. When light was emitted from a distant galaxy, that galaxy was close to us. The universe was much smaller. But as the light traveled toward us, space itself expanded. The galaxy moved away from us. By the time the light reached us, after a journey of billions of years, the galaxy is far, far more distant than it was when the light was emitted. This expansion of space itself is crucial to understanding the universe. It is not that galaxies are moving through space, like cars on a highway. Rather, space itself is expanding, carrying the galaxies along with it. This is a subtle distinction, but it is profound, because it means that when we look at a distant galaxy, we are not looking at what the universe looked like at a fixed distance away. We are looking at what happened at a very early time in the universe, when the universe was very young. Now imagine this. Imagine that James Webb observes a galaxy so distant that the light has traveled for 13 billion years to reach us. That light was emitted when the universe was only 500 million years old. When James Webb analyzes the light, it breaks it down into a spectrum, like white light passing through a prism and splitting into a rainbow. And in that spectrum, scientists can detect the signatures of different elements. Iron creates certain colors. Oxygen creates other colors. Carbon creates others still. And from the pattern of these colors, from the spectrum of light, astronomers can determine what elements are present in that galaxy. And here is where the mystery deepens. Some of these ancient galaxies contain heavy elements. Elements like iron and carbon and silicon. These elements are not created in the Big Bang. The Big Bang produces only the lightest elements, hydrogen, helium, and tiny traces of lithium. All the heavier elements, carbon, oxygen, nitrogen, iron, gold, everything beyond helium, are created inside stars. Stars forge these elements in their cores through nuclear fusion. When stars die, they scatter these elements back into space, where they can be incorporated into new stars and planets and galaxies. So if an ancient galaxy contains heavy elements, it means that a previous generation of stars must have already lived and died in that galaxy. That previous generation must have formed, burned through their fuel, and exploded, all before the light from this galaxy began its journey to us. And this takes time. A lot of time. Billions of years, in fact. Yet we are seeing evidence of this in galaxies that existed only a few 100 million years after the Big Bang. This is the paradox. The chemical evidence suggests a long, complex history, but the chronology suggests insufficient time for that history to have occurred. Unless something very different is happening. Some researchers have proposed that James Webb might be misidentifying the distances to these galaxies. Perhaps the red shift, the way light stretches as space expands, is being misinterpreted. Perhaps these galaxies are not as distant as we think, which means they are not as ancient as we think, which means there is more time for them to have developed. But the data has been checked repeatedly. The methods have been verified. The measurements seem sound. Others have proposed that the early universe operated very differently than we expected. Perhaps the fundamental constants of physics were different in the early universe. Perhaps gravity worked in unexpected ways. Perhaps dark matter was distributed in ways that allowed structures to form much faster. These are possibilities. They are being investigated. They are areas of active research. But there is another possibility. One that some physicists whisper about in hallways and conferences. One that has begun to appear in published papers, albeit cautiously, with all appropriate caveats and qualifications. What if the universe we observe is not homogeneous in time? What if different regions of space experience different histories? What if, in some sense, our universe inherited structures and histories from a cosmos that came before? This idea, strange as it sounds, has a precedent in physics. When quantum mechanics describes the behavior of atoms and particles, it relies on the concept of superposition. A particle can exist in multiple states simultaneously until it is observed. A radioactive atom can be both decayed and undecayed until its state is measured. This is not because our knowledge is incomplete. It is because, at the quantum level, particles genuinely exist in a state of superposition. Now, imagine a version of this for the entire universe. Imagine that the Big Bang was not a single, unique event, but rather a transition between states. And imagine that in this transition, certain structures from the previous state were preserved, inherited into the new universe. The light from these structures would then carry information about their true age, not the apparent age since the Big Bang. They would appear impossibly old, impossibly mature, because they would actually be impossibly old and mature relative to the standard timeline. This is highly speculative. This is philosophy dressed up as physics. And yet, it is the kind of thinking that is beginning to emerge, tentatively, in response to the observations that James Webb has provided. But there is more. There are other anomalies in the data. The distribution of galaxies across the early universe does not match what we would expect if galaxies formed randomly under the influence of gravity. There are patterns. There are structures. There are arrangements that suggest something more subtle is happening. And James Webb has revealed these patterns with greater clarity than ever before. Some scientists have noticed that certain frequencies of light coming from the early universe seem to be suppressed. Certain wavelengths of light appear to be blocked or absorbed. This could suggest the presence of barriers between our universe and something else. It could suggest that our universe is not isolated, but is interacting with some other realm, some other space, some other dimension that we do not normally perceive. This is wild speculation. This is the frontier of thought where science becomes philosophy, where observation meets imagination, and yet it is not unreasonable. It is not anti-scientific. It is the natural response of a rational mind to data that challenges fundamental assumptions. As you allow your consciousness to rest with these ideas, as you contemplate the possibility that the universe might be far stranger than we have imagined, you might feel a sense of vertigo, a sense that the ground beneath your feet, the ground of certainty and understanding, has become less firm. This is natural. This is healthy, because it means you are beginning to grasp the true scope of the mystery. The universe is not something we have solved. It is something we are only beginning to understand. And that realization, that humble realization, is perhaps the most important step in any journey toward genuine knowledge. The light continues to travel toward us, carrying its ancient messages. And we, standing here at the edge of space and time, are only beginning to learn how to read those messages. The signals from elsewhere are faint, but they are real, and they are changing everything. Imagine now that you are a physicist. You have spent your entire career studying one particular model of the universe. You have published papers based on this model. You have taught it to students. You have based your entire professional identity on the assumption that this model is essentially correct. And then, one day, you see data that contradicts your model. Not contradicts it slightly, not presents minor complications, but contradicts it fundamentally in ways that seem almost impossible to reconcile. This is what has happened in cosmology in recent months and years. The standard model of cosmology, the lambda cold dark matter model, or lambda CDM, has been the dominant framework for understanding the universe since the 1990s. It is built on the foundation of inflation theory, the idea that the universe underwent a period of exponential expansion in its earliest moments, and it incorporates observations about the expansion rate of the universe, the properties of the cosmic microwave background, and the distribution of galaxies. It is a beautiful model. It explains a great deal, and it is beginning to show cracks. These cracks do not necessarily mean the model is wrong. It may be incomplete. It may need modifications. It may require the addition of new elements, new components, new types of matter or energy that we have not yet discovered. But the cracks are becoming harder to ignore. And as they become harder to ignore, physicists are forced to ask increasingly radical questions. One of these questions concerns the very nature of inflation itself. Inflation theory was invented to solve several problems with the Big Bang model. It explained why the universe is so uniform in different directions. It explained why we do not observe certain types of cosmic defects that the theory predicts we should see. It explained the seeds of structure, the tiny quantum fluctuations that grew under gravity into galaxies and clusters of galaxies. Inflation theory was elegant. It solved problems. And yet, increasingly, physicists are wondering if inflation theory itself might be incomplete. Some researchers have proposed that inflation might not have been a single event, but rather a complex process with multiple phases. Perhaps inflation happened at multiple different rates in different regions of space. Perhaps the universe is much larger than we can observe, with different regions undergoing different evolutionary histories. Perhaps what we call the universe, the observable universe that we can see with our telescopes, is just a small bubble within an infinitely larger cosmos. This idea, called the multiverse or the cosmic landscape, has become increasingly popular in theoretical physics. The notion is that there might be infinite numbers of universes, each with different physical laws, different constants, different structures. Our universe is just one universe among an infinite multitude. We happen to live in a universe where the laws of physics permit stars, planets, and life. But there could be other universes where gravity is stronger or weaker, where the speed of light is different, where time operates differently, where matter does not coalesce into galaxies at all. If this is true, it raises profound questions. It means that what we have always thought of as the universe singular, unique, special is actually just one instance among infinite possibilities. It means that the particular laws of physics we observe are not the only possible laws. They are simply the laws that happen to govern our corner of reality. And it means, more troublingly perhaps, that some of the observations made by James Webb might be explained if our universe is younger than we thought, or if it is actually a daughter universe spawned from an earlier, larger universe, inheriting the structural complexity of its parent. There is a physicist named Roger Penrose who has proposed something even more radical. He has suggested that the universe might be infinite in both directions of time, that before our Big Bang there was another universe, going through its own expansion and eventual decay, that the infinitely distant future of that old universe becomes the infinitely dense Big Bang of our universe. He calls this conformal cyclic cosmology. It is highly speculative. Most physicists do not accept it. But it is a serious proposal from a serious physicist, and it has intrigued colleagues and sparked research. What makes this idea interesting in the context of James Webb's observations is this. If the universe is cyclic, if what we call the Big Bang is actually the transition from one cycle to the next, then the earliest structures we observe might be remnants from the previous cycle. They would be genuinely ancient. They would have genuine histories spanning billions of years. But these billions of years would have occurred before the Big Bang, in the previous universe. From our perspective, looking back from within our own cycle, they would appear impossibly old, impossibly mature. They would appear to violate our understanding of cosmic time. But they would be doing no such thing. They would simply be telling us the truth about what actually happened. This is not established science. This is not something you will see in elementary astronomy textbooks. But it is serious scientific speculation, motivated by real observations, guided by mathematical principles, and developed by accomplished physicists. And it represents a fundamental shift in how we are thinking about the cosmos. What is happening now in the field of cosmology is a kind of creative ferment. The old certainties are being questioned. New ideas are being proposed. Some of these ideas will ultimately be proven correct. Others will be shown to be wrong. But the process itself, this process of question and exploration and imaginative speculation, is the engine of scientific progress. It is how understanding advances. It is how we move from partial knowledge toward deeper knowledge. And it is happening now in response to James Webb's observations in real time. You are living through a moment of scientific transformation, a moment when the foundations of our understanding are being gently shaken, when the map of knowledge is being redrawn, when the universe is revealing that it is more complex and more mysterious than we had imagined. As this sinks in, as you rest with these thoughts, you might feel something that could be called productive doubt, not the paralyzing doubt that comes from fear or confusion, but the generative doubt that comes from recognizing that reality is more intricate than our current models capture. This doubt, this humble recognition of the limits of our knowledge, is actually a source of comfort, because it means there is more to learn. It means that the universe still has secrets to reveal. It means that the mystery persists. And in the persistence of mystery lies an invitation to deeper understanding, to continued exploration, to the ongoing human endeavor to comprehend the cosmos in which we find ourselves. The cracks in the theories are spreading, and through those cracks, light is beginning to shine. Light from beyond our current understanding. Light from regions of possibility that we are only beginning to explore. Now let us move into a realm of even greater subtlety. Let us consider the patterns that underlie the universe. Patterns so fundamental that they are almost invisible, yet so powerful that they govern everything from the behavior of atoms to the distribution of galaxies across cosmic distances. Physics, at its deepest level, is the study of symmetry. When Einstein developed his theories of relativity, he did so by considering the symmetries of space and time. The fact that the laws of physics should be the same in all locations in space. The fact that the laws should be the same at all times. The fact that motion in a straight line should be indistinguishable from rest. These symmetries simple, almost obvious seeming led to revolutionary conclusions about the nature of space, time, and gravity. Similarly, quantum mechanics is built on symmetries. Different types of particles are understood through the lens of different symmetries. Electrons, quarks, photons, these all appear in response to deep mathematical symmetries in the fabric of reality. And when physicists have discovered new particles, they have often done so by following the implications of these symmetries. They have said, if reality has this particular symmetry, then this particular type of particle must exist. And then, through experimentation, they have confirmed that the prediction is correct. This power of symmetry, This ability to understand the deep structure of the universe by contemplating its symmetries is one of the most profound insights of modern physics. And it is within the study of symmetries that some of the most interesting interpretations of James Webb's observations are emerging. Some researchers have proposed that the universe might possess a hidden symmetry that connects our cosmic epoch with a previous cosmic epoch. A symmetry that would allow structures from one universe to be inherited by another. A symmetry that would explain how galaxies could appear so ancient, so mature, so impossibly well developed in the young universe. To understand this, imagine looking at a photograph and its mirror image. The photograph and its mirror image possess a symmetry. They are reflections of each other. Now imagine that this symmetry extended, not just to visual appearance, but to the deep structure of reality. Imagine that the forward direction of time in our universe had a mirror symmetry with the backward direction of time in an earlier universe. What was the future of the old universe becomes the past of the new universe. What was the remote past of the old universe, when structures were already mature and developed, becomes the remote past of the new universe, when those structures are inherited, already formed, already ancient. This symmetry is not something we observe directly, but it could potentially explain the observations that have troubled cosmologists. It could explain why James Webb sees galaxies that appear far too old, because they are not too old. They are actually as old as they appear, but their age is measured in the time of the previous universe, not the time since the Big Bang. Now you might ask, where does this symmetry come from? Why would such a symmetry exist? And the answer, according to some theoretical physics, is that it might be an inevitable consequence of the deep mathematical structure of the universe. Just as the equations of general relativity necessarily imply that massive objects curve space and time, the equations of some deeper theory of gravity, a theory we have not yet fully developed, might necessarily imply the existence of these cyclic symmetries. There is a principle in physics called the principle of least action. It states that nature, in some sense, takes the path of least resistance. Systems evolve in such a way as to minimize a quantity called the action. This principle seems to be deeply embedded in the laws of physics. And when physicists have explored the mathematical consequences of extremizing the action for the universe as a whole, for gravity and spacetime itself, some intriguing possibilities emerge. One possibility is that the universe naturally settles into a state of cyclic existence, not because some external force compels it, but because such cycles represent the minimal action, the most natural state. Another possibility is that the universe might naturally evolve towards states where information is preserved, where no information is ever truly lost, even in the most extreme circumstances like black holes or cosmic catastrophes. This information preservation might require that old universes leave traces in new universes, that structures from the past cosmos persist in the new cosmos, that time, rather than beginning at a single point, cycles through infinite transformations. These are deep ideas. They rest on mathematical ground that most people never walk upon, but they are not unreasonable. They are not anti-scientific. They are the natural evolution of physical thought when physicists take seriously the implications of the laws they have discovered. And what makes this particularly interesting is that James Webb's observations might be providing evidence for these ideas, not conclusive evidence, not evidence that compels belief, but tantalizing hints, subtle suggestions that something more profound might be happening beneath the surface of what we observe. Consider, for instance, the distribution of galaxies in the early universe. As I mentioned before, it is not random. It shows patterns. There are regions of dense clustering. There are regions where galaxies are sparse. And the scale of these patterns, the typical distance between clusters, the typical size of voids, seems to match predictions for structures inherited from a previous universe. This might be coincidence. The patterns might be explained through other mechanisms, but it is worth noting. It is worth investigating. Similarly, there are subtle asymmetries in the cosmic microwave background radiation, the afterglow of the Big Bang, that have troubled cosmologists for years. These asymmetries might be explained if the Big Bang was not a fresh beginning, but a transformation from one state to another. If the initial conditions of our universe were inherited from a previous cosmos, rather than emerging from pure randomness, certain patterns would be expected, and these patterns might correspond to the asymmetries we observe. None of this is certain. None of this should be accepted as fact, but all of it deserves serious consideration. All of it represents the frontier of cosmological thinking, the place where our most advanced observations meet our deepest speculations about the nature of reality. As your mind drifts through these concepts, as you contemplate the idea that the universe might possess hidden symmetries, and that these symmetries might connect our cosmos to others, you are participating in the ancient human endeavor to understand the eternal structure of existence. You are thinking the kinds of thoughts that Einstein and Planck and Hawking thought. You are exploring the regions of possibility that still lie open, still undiscovered, still waiting to be understood. The patterns are there, hidden in the data, encoded in the light that has traveled across billions of years to reach us. And slowly, patiently, with instruments like James Webb, with theoretical frameworks that grow more sophisticated with each passing year, we are beginning to perceive them. Imagine now that you have journeyed in your mind through billions of years of cosmic history. You have traveled backward from the present day, through epochs of galactic evolution, through the formation of the first stars, through the cooling of the primordial plasma, back toward the very beginning of observable time. And now you approach the threshold, the moment that we have always thought of as the Big Bang, a moment beyond which we cannot look, because time itself is said to have begun at that moment. But what if you could pass through that threshold? What if, rather than a hard boundary, a true beginning, the Big Bang was actually a subtle transition, a place where one regime of physics gave way to another, but where neither regime was truly the first? Imagine passing through that threshold and finding yourself in a different universe. A universe with different physical constants, different laws of physics. Perhaps a universe that operated according to rules so alien that you could scarcely recognize it as a universe at all. Or perhaps a universe that was simply older, larger, more developed. A universe from which our universe was born. This is not reality, of course. We cannot actually pass through the Big Bang threshold. We are imprisoned in our own universe. Our observations can only reach back so far. Our theories can only speculate so much. But the speculations are worth considering, because they point towards something profound. They suggest that the division between universe and cosmos, between what is and what might be less absolute than we have always assumed. Some of the most recent speculations in theoretical physics have to do with what is called the multiverse, or meta-universe, or cosmic landscape. The idea is that our universe exists within a much larger structure, that there are regions of space, and perhaps regions of some higher dimensional structure that contain other universes. Universes with different physical laws, universes with different constants of nature, universes that may or may not support the existence of matter, energy, life as we understand it. In such a landscape, our universe is one island among infinitely many islands. And what we observe as the Big Bang might be the moment when our particular island was separated from the larger whole, when our region of space was somehow isolated, quarantined, set apart to develop according to its own particular laws. Some physicists have proposed that universes might even be able to give birth to other universes. A black hole in one universe might be a Big Bang in another. The interior of a black hole might contain an entirely separate cosmos. In such a scenario, universes would form a vast tree of parentage and descent. Our Big Bang might have been caused by the collapse of matter in a previous universe. And black holes in our universe might themselves contain the seeds of future universes. These ideas are not established science. They are not things you will find in mainstream physics textbooks, presented as facts. But they are being seriously studied by legitimate physicists. They are being written about in peer-reviewed journals. They are being explored as possibilities worth considering. And what is remarkable is that James Webb's observations, rather than ruling out these ideas, seem to provide hints that they might be along the right track. The impossibly old galaxies, the unexpected patterns in the distribution of matter, the subtle anomalies in various observations. All of these could be explained if the universe is younger than we thought, or if it inherited structures from a previous cosmic epoch. Now, here is where we must pause and consider something important. The ideas we are discussing: cyclic universes, inherited structures, cosmic landscapes, symmetries between epochs, these are at the very edge of what can be called science. They touch on philosophy. They border on metaphysics. And yet, they are not unscientific. They are not anti-rational. They are the natural extension of scientific thinking into regions where observation becomes difficult and speculation becomes necessary. Science is built on the foundation of evidence and logic. But as we push toward the boundaries of the observable universe, toward the earliest moments of time, toward the deepest questions about existence itself, evidence becomes scarce. The observable universe is limited. We cannot see beyond the cosmic horizon. We cannot go back before the Big Bang. We cannot access regions where the physical laws might be radically different from what we know. In such circumstances, the tools of science experimentation, observation, falsification become limited. But we do not abandon science. Rather, we extend it. We combine observation with logical inference. We use mathematics to explore the consequences of different hypotheses. We search for subtle evidence that might support one possibility over another. And we remain humble about the limits of what we can know. This humility is perhaps the most important aspect of what we are discussing. Because the universe is under no obligation to be simple. It is under no obligation to conform to our expectations. It is under no obligation to have begun where we think it began, or to operate according to the laws we have discovered. The universe simply is what it is. And our job, as curious beings attempting to understand, is to listen carefully to what the universe is telling us, and to follow the evidence wherever it leads, even when it leads to uncomfortable places, even when it challenges our deepest assumptions about the nature of reality. As you rest with these thoughts, as you allow them to settle in your consciousness like sediment in still water, you are approaching the threshold, the boundary between what is known and what is unknown, the place where certainty gives way to possibility, the place where the universe begins to reveal its deepest secrets. And it is in this liminal space, this threshold between knowing and mystery, that true understanding begins to emerge. Not the false certainty of someone who believes they have all the answers, but the true clarity of someone who has glimpsed the vastness of what remains to be learned and found it beautiful. And so we arrive, slowly, gently, at the end of our journey through the night. But it is not an ending. It is a resting point, a moment where we pause and allow our consciousness to settle into the immensity that surrounds us. The observations from James Webb, the questions they have raised, the mysteries they have revealed, these do not end with this conversation. They continue. The cosmos continues its eternal expansion. The light from distant galaxies continues its journey toward us. The physicists continue their work, refining theories, seeking evidence, following the universe's whispered hints toward deeper understanding. But for you, right now, in this moment, what matters is not the conclusion, but the contemplation. Not the answers, but the questions. The feeling of floating in a cosmos so vast, so old, so full of mystery, that all the concerns of daily life become, for a time, small and manageable. The recognition that you are made of the same atoms as distant galaxies. That the iron in your blood was forged in the heart of a dying star. That the calcium in your bones came from supernova that exploded before our sun was born. That you are, in the deepest sense, made of star stuff. Made of the universe contemplating itself. Imagine, if you will, that you are floating in the deepest part of space, There are no galaxies near you, no stars, only the faint background radiation from the Big Bang, a gentle glow of microwave radiation that fills all of space, the afterglow of creation itself. You are utterly alone, utterly peaceful, utterly connected to everything that exists. And in this place, in this profound solitude, you begin to contemplate what it all means. What does it mean that the universe appears younger than it should be? What does it mean that galaxies matured impossibly fast? What does it mean that James Webb has looked deeper into the past and found mysteries rather than answers? Perhaps it means that the universe is more generous than we imagined, more full of time, more full of possibility, more full of paths that could have been taken, more full of realities that might exist in some other corner of the cosmic landscape. Perhaps it means that what we call the Big Bang is not the ultimate beginning, but one moment in an eternal cycle. One transformation among infinite transformations. One version of creation among endless versions. Or perhaps these observations mean something else entirely, something that no one has yet conceived of, something that requires new ways of thinking about reality, new mathematics, new frameworks, new languages in which to describe the universe. The future will reveal these things. But we need not wait for the future. We can rest right now, in the present moment, knowing that the universe is vast enough to contain all these possibilities, vast enough to hold mystery and wonder, vast enough to sustain human curiosity for eternity. The universe, if the physicists are right, and they might be, if the universe is cyclic, if it transforms and renews itself in endless cycles, then it is also immortal. It will not end. It will transform. It will reinvent itself. And perhaps, in some distant epoch, long after our sun has burned out, long after our galaxy has merged with another galaxy, long after the last stars have died, and the universe has grown cold and dark, perhaps in some distant epoch, a new Big Bang will occur. A new transformation. A new beginning that is also an ending. A new universe that is also a rebirth. And in that future universe, perhaps there will be creatures like us, curious creatures who look up at the night sky and wonder, who build instruments to peer deeper into the past, who ask questions about the nature of reality, who seek to understand the cosmos in which they find themselves. And perhaps those creatures will find the same mysteries that we have found. Perhaps they will discover the same paradoxes. Perhaps they will ask the same questions. Perhaps they will come to the same realizations, that the universe is larger than we can comprehend. That mystery persists at the very heart of existence. That the eternal question is more important than any temporary answer. This is the wisdom that the cosmos offers us. Not certainty, not closure, but the recognition that the journey of understanding is itself the destination. That the search for truth is itself the truth. That the process of asking questions is itself the answer we seek. As your breathing slows, as your body becomes heavier, as the boundaries between your consciousness and the larger cosmos begin to blur and dissolve, you are approaching sleep, that most mysterious of states, that nightly death and resurrection where your mind releases its grip on the waking world and enters a realm of dreams, of processing, of healing. And in sleep, you might dream. You might find yourself floating among stars. You might witness the birth of galaxies. You might travel through wormholes and nebulae. You might experience the vast, serene peace of empty space. Or you might simply rest in darkness, and that darkness might be enough. That darkness might be everything. The universe rests too, in a way. Stars are born and die. Galaxies collide and merge. Space expands and contracts. And yet beneath all this motion, all this change, all this cosmic evolution, there is a kind of rest, a stillness at the heart of things, a peace that underlies the drama, a silence in which all the noise of the cosmos echoes and fades. You are part of this. Your breathing, your heartbeat, your consciousness. These are all vibrations in the vast symphony of existence. And like all vibrations, All waves, they eventually dissipate. They return to stillness. They become one with the cosmic silence from which all things emerge and into which all things eventually return. As the night deepens around you, as the stars wheel overhead or sleep claims your vision, know that you are held. Held by gravity, held by the cosmic web of matter and energy, held by the mathematics that underlies existence, held by the eternal cycle of creation and transformation and rebirth. The James Webb Space Telescope continues to observe. Scientists continue their work. Theories are refined. New observations challenge old assumptions. The universe continues to reveal its secrets, one whispered hint at a time. But this is not your concern, no. This is not what you need to focus on as you rest. All you need to know is this: the universe is vast. It is ancient. It is beautiful. It is full of mystery. And you are part of it, woven into it, made from it. And as you drift now into sleep, as your consciousness expands into dreaming, carry with you this knowledge, that you are connected to all that exists, that your atoms are cosmic atoms, that your consciousness is the universe contemplating itself, that in rest and in waking, in life and in sleep, in all the moments of your existence, you are never separate from the whole. The mystery persists. The questions continue. And yet, there is peace in not knowing. There is peace in acknowledging the limits of understanding and finding, in that acknowledgement, a kind of freedom. The freedom to wonder. The freedom to dream. The freedom to rest. And so, as the night carries you toward sleep, toward that place beyond waking where time seems to stop and eternity seems to rest in your hand, remember this: the universe is speaking to you, not in words, but in the beauty of starlight, in the ancient light from distant galaxies, in the very structure of existence itself. And it is saying something simple: be at peace, rest. The cosmos will continue its dance. The stars will continue their burning. The galaxies will continue their rotation. And you, for this moment, for this night, can simply rest, knowing that you are held, knowing that you belong, knowing that the universe, in its own slow, patient way, is offering you everything you need. So close your eyes now, if you have not already. Let the darkness gather around you like a blanket. Feel the weight of rest settling into your body. Let your breath slow. Let your heart settle into its rhythm. Let the concerns of the day drift away like clouds moving across a night sky. And know that somewhere, 1,000,000 miles away, an instrument is watching the ancient light arrive, watching the universe reveal its secrets, watching, for all of us, the ongoing revelation of what it means to exist in a cosmos so vast, so old, so beautiful, that words can barely touch it. The universe has spoken, and it has told us something simple and profound. That mystery is not something to fear, that the unknown is not something to avoid, but rather, that mystery is the great gift, the eternal invitation, the cosmic love letter that the universe sends to all conscious beings who are willing to listen. Listen still, as you sleep, as you dream, as you rest in the embrace of the night. Listen to the silence beneath all sound. Listen to the stillness beneath all motion. Listen to the eternal voice of creation, speaking in the language of starlight and gravity and the slow unfolding of time.